So, workflow overview. This is the workflow that I use to take an existing CAD drawing or part and make renders and animations out of it, of course using Blender. I'm not going to go into loads of detail on each step. This is just to give you a full start to finish process that you can use for your own projects. We're only going to do a single part here just to show you the whole process. Typically you would do this multiple times for multiple parts in a bigger assembly, and then you would combine it all at the end. If there's anything that you want me to go into more detail in, then just leave a comment and I'll do a video on it. And of course there's also Blender for Engineers, where I'll walk you through this kind of process for a lot more complicated models, which is the first link in the description. So if you're interested, just give it a read over and you'll be supporting the channel. Right, let's get started. So this is my startup file, which is also available in Blender for Engineers if you want to just download it. I'll do another video showing you the kind of overall setup for that as well. What we're going to do is we're going to use the McMaster-Carr component library, which if you have used CAD before, you should be familiar with. Also, this is a really fast website, just as a random point. What we're going to do, we're going to model one of these, a little routing eyebolt here. Now, it's not got a thread. Again, this is just to make it a lot more simple to model and just make this video quicker, because my last few videos have been nearly an hour, and I know a lot of you can't be bothered watching that. I wouldn't blame you. So what we're going to do is, you can download it as a 3D model here, but what I'm going to do instead is I'm going to assume this is a case where we only have the drawing. So what we're going to do is we're going to download it as a 2D PDF here. So we're just going to download this. I'm going to go into the downloads, just here, and copy this into this folder here. Now, typically you would just import something like this into Blender, but because it's a PDF, we hear File Import, Blender can't really do PDFs. I imagine there are some add-ons for it, but we're not going to go into all of that complicated detail. What we're just going to do, I'm going to use a little program called Inkscape that I quite use. You can use like Photoshop or GIMP or any other kind of programs. But what we're going to do is we're just going to go Desktop, Documents, where is it? Models, just to where I've saved this. I'm going to open this PDF and hit OK. So the default settings. We're going to open this PDF here, and we are going to use this program to just convert it straight into a picture. So we're going to get a PNG, we're just going to do like, I don't know, 4096, just to make sure we get some half decent resolution. Export, and I'll just save it next to it. Now we can go File, Import, or actually no, sorry, what we're going to do, just open this here, put Blender there. We're going to take this, just drag it in, straight like that. There we go, okay. So now we have the actual kind of dimensions done here. Now the way it's exported it doesn't have a background here, so you might want to, I believe there's some options in here, you can change how it's imported, but it should be fine. So now the next step is scaling it properly. Now this is obviously an imperial, so what I'm actually going to put this image in the references tab here. So what you can actually do in Blender, if you just go Add Mesh Cube, you can actually type in the dimensions directly here, and that should be accurate. So now if you select the image, we can just scale it down here, and if you hit delete on your numpad, it'll zoom into what you have selected. So now we can put that there. And of course, if you were modeling straight from a CAD part, you could just import the part directly. Typically, you want to convert it to something Blender can use. Blender can typically can use STL files, which are used for 3D printing, so that's generally quite good. That's a good one to import it as. So we just put that there. It doesn't have to be perfect, but there we go. I'm also just going to move this on the Z-axis just to center it on the the center of the kind of eyebolt itself here. And now, when you go into this view, it doesn't exist anymore. So what you want to do is you want to go into this, select your image, go into the image tab here, and then select perspective, and then for these, just set the default and both, and then you can see it wherever. Cool. So now, what we're going to do, we're going to take, because these are nicely aligned, we can just duplicate this image and send it over here as well. Just center that there. And then if we set the transport pivot point to the 3D cursor, we can rotate it around the center like that. And then you can pull that to, say, there. Pull that to there. But now when you go into your perspective views, or your orthographic views, you now have orthographic drawings of it. You don't really need a top down, but you can figure out the rest of it from this. So, very quickly, we're just going to do a model of this. This is not going to be perfect by any means. Again, this is just to show you the workflow. So let's start with a sort of 8 vertex here. We'll just model the shoulder first, or rather the kind of thread. Well, not thread because it's not actually got any threads on it, but the actual kind of bolt section here. We're just going to start here. Again, does not have to be perfect. You can type exact dimensions. Obviously, in the Blender, you can do, I don't know, yes, that, and then just negative. Just flip it like that. Also, you want to flip the normals here. So if it doesn't look like this, what you want to do, you want to turn on backface culling. So normally it'll look like this, right? So you can see both the kind of outer face and the inner face. You want to turn on backface culling because this will enable you to see whenever there's an issue with the normals. So the normal vectors in each face just tell you which way is out. So obviously we want it to be the other way around. So if we just hit recalculate outside or just flip, then that means the outer face is actually the outer face and you can't see the inner face. That's just a good tip for models generally. But it means a lot of your modifiers that use normal vectors will work properly. So let's just do a quick, very quick sort of model of this. Again, doesn't need to be perfect. I'm going to use some general good practice just to make it look all right. Scale that out there. Let's just model that to a bit here. And then we can bring that in a little bit more. Bring that to there for now. Cool. Then we can model the eye here, and there's a perfect shape for this. There's a torus in Blender. Actually, what I'm going to do, we're going to get I don't really think it works with outer and inner diameters. The way it seems to work is you get your major and minor radius. So let's just set this to this for now, and then this to like 0.2. Okay, so let's divide that by 2 real quick. Oh, doubled that. Nope, I've screwed up. Okay, let's do that again. Okay, you can tell this is very sort of hasty. I'm just doing this completely off the cuff here. So let's see, what would we want as our kind of radius here? Probably would be 3/4. No, it would not be. No, not 3/4. Not be that. Let's just divide that by 2 because that'll be the diameter. There we go. Perfect. Then we can make this, I don't know, something like that. Perfect. And now what we want to do, we want to rotate it around the x-axis here. So by 90. And we're just going to try and line some of these up. So what we're adjusting here is major segments. I'm totally stumbling, as you can tell, stumbling all of my words here because I'm just rushing this. But that's fine, doesn't really matter. 16 too little. 16 is probably too little. I think 16 will be fine. And then for these segments, we can make this maybe 8 will be good. We're trying to match up this here. Again, doesn't have to be perfect because this is all going to be subdivided and connected anyway. Let's go with that. Then we can delete these faces. And let's hook up, oh, not there, let's hook up this to this. And then we can kind of connect that all there. Okay, this is a pretty sketchy looking bolt, but it's not too bad. And then we can pull that out just to kind of start adjusting how this actually connects together. And let's add our modifiers. So we're going to add a bevel. We're going to make this like 0.1 millimeters. Something like that. We're going to set 2 segments, do it by weight. Profile, 0.7. This is just a general process I use for all models. And now we can select the sections that we want to have sharp edges, which is really only this one at the moment. Or rather, okay, it'll be this one as well, but we will then pull that up to about there. And now we can add our subdivision. And what we're going to do as well, we're going to add another little bevel here just to kind of round this a little better. And then we're actually just going to scale this out to about there. Take this whole segment here, scale this. Again, I'm not going into all the details on how exactly I would do these kind of models, purely because this is a bit of workflow. And there we go. Okay, so we've got a sort of sketchy but generally alright looking eyeball model here. So this is what I would mean if you were to do this for a bigger assembly. You would want to do this for multiple parts. Actually, one of the wee things you can probably do here, you can probably pull this, I would imagine, up to there. Just give this a try, just on the fly, see if it works. Again, Blender's a lot of trial and error. You can just sort of give things a try, and if you turn up your undo steps, if you go preferences, where is it, system, undo steps, crank that up at defaults to like 16 or something tiny like that. I've got it up at 128. That means you can go all the way back and just undo things if it doesn't work out for you. So feel free to just try things and just experiment. So we're going to build it here. And it kind of, as you can see in the kind of reference here, that's not too far off. It's not bad. Again, this is not meant to be perfect. I'm just doing this to show you the workflow. So let's just pull that up there, something like that. That'll do. Okay, cool. So now the next thing we would do, we're going to apply a material, like a very simple material. We're just going to come here. We're just going to call it like steel or something. And actually, what I can do, we're going to, if you go here for shader type and you set this to world, and I have this environment texture node plugged in here. If you just create one of those, you can then get HDRI. I quite like, where's it called, this little studio one. So now if you go into render view and you give it a second to load the image, you've got this sort of studio view around you, and it just gives you some really nice lighting. And make sure it's a HDR file, because that if it's just an image file, you won't get these like really actually bright lights. It'll kind of cap off, you won't get these super bright lights. They'll actually give you lighting in your scene. So now if we go back to shader type object, we can just make a quick material, metallic 1, color down to like here, roughness, let's just do about there, something like that. Now you can play with a lot of the other materials. I do have a tutorial on how to do some metal materials. If you want to check that out as well, I've got some other tutorials on other parts of this process as well. And like I said, if you've got any questions or anything that I don't explain particularly well, just leave a comment and I will make another video on it. Okay, so now, assuming that you would have this for, say, multiple parts, if you had like a bigger assembly, again we're only doing one part here, you can now take this model and make some sort of like animations or renders out of it, right? So if we get rid of the references here, we've got our just plain eyeball model. And let's just quickly, I've got a camera set up here. Again, I've got a video on camera setups if you want to check that one out. Let's just put that to like there, so it doesn't really matter. Bring this in quite far, scale this down so you can see what you're doing. And now if we go into this view I've set up here, this is more for animation, but it works for this sort of thing as well. If you just hit 0, there we go. So this is my sort of proper render view. And now you can see this is it's starting to clip here. So what you can do, you can go into the camera settings down here, clip start, make this like 0.01 millimeters, and then make this like 1, just to stop the Z fighting. Which again, I explain a lot more in detail in my camera video. So let's just pull this to like the middle of the part here. And you can be more precise with all this. This is just very quick and hasty. So let's say, what do we want? Let's do a quick thing of it like on a table or something like that. So we just add a cube here. You can't see it because it's so big. Where have you gone? No, it's so small actually. Right one round. There we go. So let's just make a quick little table of some kind. Obviously, you can be a lot more fancy with this. You can have like nice backgrounds and all of this stuff, which can be quite nice, but I'm just going to do a quick little table model here and just kind of roughly place it where it might sit. That, something like that, right? There we go. And now, if we get the sort of focus point here, bring that round to it there, right? Or like here. And now you can give this a kind of, I don't know, I quite like a kind of light pink yellowy material, make that quite rough. That tends to give some nice kind of colour to the scene here. You can also do like gradients and whatnot. Of course, you can also do a lot of animations and that kind of thing. You can animate the part moving around, you can animate it moving around within other parts. So this would be sort of for like a product visualization style thing. Say if you're making like a pitch, if you're trying to get, say, funding for your engineering startup or whatnot, and you've got a kind of basic concept design, you can take this sort of thing and make some nice, fancy, realistic looking renders to like wow investors, that kind of thing. You can also do, say if you want like a nice cutaway view, this is where the tricks you can do. It's a wee bit slow because of how Boolean works, but for renders it's fine. If you add a Boolean modifier here, I'll probably do another video on this actually because this is quite a big process. If you get the Boolean modifier here and you select this object here, and then for this kind of cutter object you have here, you can just go turn on these extra restrictions and make it not show up in the viewport or render. If you just make it visible there, or not visible there actually, and then cut it away like that, you can see it's got this kind of cutaway now. And because we've turned off this render thing here, it doesn't appear in renders. And say if you want to make this, I don't know, maybe there. Again, it's quite slow when you start moving things around like this because of just how Boolean works as a modifier. But you can see here we've now got this fancy cutaway. I know it looks a bit sketchy there, but there's some other stuff you can, again, this is a more complicated topic. But it's just an example of the kind of things you can do with Blender that would be quite difficult to do with a CAD program, and especially just the pure realism you can get. Considering it's a free software, it's free and open source, so there's a lot you can do with Blender. It's very, very powerful, and I really do think that anyone in engineering should at least give it a try and give learning it a try. And of course, that's not to kind of brag or plug my own thing, but of course that's where Blender for Engineers comes in. That's what I essentially teach. One of the main things we do in Blender for Engineers, start with, now I'm an aeronautical engineer, so I essentially start with a aircraft type spec document, where you get the sort of basic technical specs and maybe some very, very basic sketches, and then take that into Blender and make a full sort of visualization ready like model, and then make some renders and animations out of it. And then I give you some tips on like presentation and that kind of thing. So say, of course the example is aircraft, but it would be if you're starting up like a engineering company and you've got like a Dragon's Den type thing or whatever, if you're looking for investors or if you're just looking to present your work, then it's a really, really good way to kind of show off the quality of the work that you do and just really render things out a lot better than any CAD program can do. So like I said, it's the top link in the description, so if you just have a look at the about page there if you're interested, just give it a look and you'll be supporting the work that I do and I'll be very grateful for it. So thanks for watching.